So on this one, the investigating immunoglobulin 1G using Molstar, we're going to go up here and click into 1IgG, and then we should be able to bring up our antibody. Like quick little throw around, you can see how many different polypeptides are working together for this particular protein. So you can pick out the orange one that goes all the way through, and the pink one, this green fragment, and then this kind of purple one. So the one which goes all the way around orange is one of the heavy, the other heavy being the pink, and then these smaller ones, these light chains, are being purple and green. Over here you can see one of the antigen binding sites, which is bound to this bit. So in terms of zooming in, you can scroll through, you can use the appropriate kind of tool if you're on a tablet or touchscreen, and you can see what it is. By hovering it over, you can pick out what the structure is in terms of that polysaccharide, or you can go up to the top and you can look at the sequence. Okay, so we can see what this 9 sugar polysaccharide actually is, and it's the same on either side. Okay. What we're going to do is delete that carbohydrate. So over here we can click on the bin, and then we can start changing things around in terms of what we want to look at. So we can click into here and let's go for a molecular surface, because our antibodies are globular. So it's a good idea to be able to see it. And then we can start to see about the surfaces. And then we can start picking out like the hinge regions. And here we can start to see that heavy chain really clearly. That's the 2 light chains as well. What we're going to do is start changing the colors around. So maybe we go into the atom and we can look at element symbol, and we can start to see where the red oxygens, the blue nitrogens, and most importantly for us, these yellow sulfurs. Okay, so we can start looking and start trying to find some disulfide bridges. Now we know that some exist around this hinge region, so we can zoom in over here and we can start doing some measurements. When you come to do measurements, you click on the cursor and you need to make sure that you're clicking onto the atom. Then you can select, and we want to like do another one, and then we should be able to do that distance. We can measure this distance. Now, in the sheet, it tells you that most are around 2.05 angstrom, or 2.05 times 10 to the minus 10 meters. So you might want to take a little bit of a mean. So let's try and find another one. So this one here, and we can add that distance, and then this one here, so it highlights it so you can see which ones you recorded. So it goes into this pink. So let's do another one. I think there's one. Let's go and try and spin this around a little bit just to see it a little bit clearer. And select this one and that one. And then add that distance. And again, it's the same kind of ones. And we can start looking at what the cysteines are that we're talking about. So in this case, it's the cysteine 225